Okay, so we're on page 329, and I want you to open your notes that we went through of graph of f prime when f is increasing, when f prime is positive, f decreasing, when f prime is negative. Critical values are zero crossing and endpoints. F prime goes from plus to minus, it's a max. F prime goes from minus to plus, it's a min, like that. Okay, so we're going to graph derivatives and use this stuff here to figure out where something's increasing and decreasing. So we know where our derivative is positive, it's increasing, negative, decreasing, critical values are zero crossing. So we're going to use your calculator and we're going to, so let's start. We're going to take the derivative of number 1. So first, take the derivative of that. Then once you take the derivative of that, you're going to enter that into your calculator. You have all of that in the notes.
I have the notes go to that's multiple notebooks, and I don't think I have that one on into it.
Just take the derivative of that. And you're plotting it. We're going to start by get the intervals of increase and you should use graphs. We're going to start with getting intervals of increase and decrease in extreme values. So we take our derivative 5x to the 4th minus 20x cubed minus 3x squared plus 56x minus 2. Then you're going to read from that graph wherever it's positive. That's going to be an interval of increasing. Now, you can use the zero crossing to figure out the exact points where it changes, and you're going to need to do that, right? So just as when we use the quadratic formula and get our zero crossings, we're going to do that to figure out where it's positive, where it's negative, and get it precisely. So let's have a good window. Okay, so something like -3 to 5 will do, or you can use a different window, but some window where you can well see those zero crossings. Now, you should see 2 zero crossings. So you're going to go second calculate. Okay. Now, if you want to get a real clear view, you can go all the way from -100 to 150, but let's just get our zero crossings. Okay, now we're going to do second calculate. Start over here. And we can throw it out there. And we can center. Okay, so second calculate. Press enter. And then to the right of it. Just and then press enter. And then this is guess and press enter again. And then write down that X value. Okay, so I think if you have a window on your Y, negative 100 to 500, that's the best view so you can see the whole thing. So it's not just a vertical line. It's also easier to see what's going on for your zero crossings. Okay, so you should see 2. So you're going to go second calculate. We're only interested in the X values here because we want to know where is it increasing, where is it decreasing. So you're going to go through each of the zero crossings. You get that other zero crossing. So you should get a first crossing around negative 1.5. Yeah. See how we do. Okay, good. Are you able to do your second calculate yes and all that? Yes. Okay, so what did you get for this zero crossing here? Yes. So that one, this one should be over here, right around negative 1.5. Second calculate, then what you get, and then we're going to get that both down, just to go after this. This is what you do. Press enter. Okay, so press enter. Now keep moving and press enter. Press enter one more time. Oops. You don't move it again. Once you do it 7 times, that's okay. So to get minus 1.49. So it's right around minus 1.5 there on the left. So what we have here is negative infinity to negative 1.5. Okay, it's positive there. So our derivative is positive. It's increasing. Now you look at the next one. Get that next one. It's close to 0, but not exactly. Now it's hard to tell at that third point whether that's actually crossing over or not. So you have to check yourself. If you just look at it, you can't tell. So the second one you should get, I have 0.04. So it should be a positive. Sorry, 2 So we have this local max right here. And you want to figure out what is the value of that local max. Okay, so we know where it's increasing and you know where it's decreasing. We know where it goes from positive to negative, we have a max. Negative to positive, we have a min. So it went from positive to negative, we have a max. Then you're going to check that third point. And see if that crosses over. If you zoom in real close, you can check that way too. So right around 0.04. So it's positive increasing, negative decreasing, positive increasing, that's this point right there. Okay, now let's get this point right here. If you zoom in at right around 2.8, you'll see it crosses over. And get what that value is for, we have 1.5.04. You should see the next value is right around 2.84. So if you do that, you should see it. Wait. This is positive. And this is also positive, but it just goes to like, this is really, this is something that is real tricky in here. So when you do your left, right on that third point, you should see you're getting your left crossing is 2.62, your right crossing is 2.84. Okay, so we went negative infinity, negative 1.5, positive, negative 0.04. 0.04, 2.62, positive 2.62 to 2.84. Negative. If you blow that up on your calculator, you'll see that it's just barely going below the x-axis there. And then 2.84 to infinity. I ran out of space. Erase this. 2.84 to infinity. You should have gotten all of those. Then pick out what we have, the rest of your notes. The inflection points are where the slope changes sign and f prime prime is 0. So the max and the min of this graph are your inflection points. So get your max and min. Show me if you didn't get your 2.62 and your 2.84.
The maximum right here. So just we stop there. Press enter. Second is going to be right there. Okay, just show you. So there's this zero crossing right there. So let's start over second calc. 2. Enter. And just to the right there. Enter guess. Enter 2.62. Okay, then you go second calc. 2. Left hand is right there. Enter. Right round. Enter. Enter. Okay, 2.84.
It just barely crosses over. If you zoomed in, you'd see it. You'd have to zoom in to see the 2.84 crossing over. Okay. So we know we have a max. We know we have a min. We know we have a max. Right now, let's get the max and mins on this graph, which should be your inflection points. We can also get our inflection points from the second derivative graph. So we can get them from the first derivative max and min, or we can get them from the zero crossings of the second derivative graph. Why don't we just do it both ways? So I want you just to use your trace button. Okay, you're just going to use trace. And let's start with the leftmost min. And we're going to estimate it with the trace button, and then we're going to go graph that derivative to get it more precisely. Get as best as you can at that minimum. So get as best as you can that minimum point on the left, using your trace to write it down. The max and min of the first derivative are the inflection points, because that's where you have a zero horizontal tangent. That's where the derivative is zero. So the second derivative is zero at the max and min.
What do you think these two functions do here in different places?
No, I wouldn't for right now. We're just using the trace.
Okay, so you should have used your trace to get your maxes and your mins. We're going to do it three ways. Everybody get that? So you have your graph looks like this. You've gotten this value, you've gotten this value, and you've gotten this value, and you've written that down, right? So for the left one, you have approximately negative 0.89. Okay. This one in here is approximately 1.15. You've gotten that, right? Just using your trace function. Okay, we're going to do it two ways now. First, we're going to use your max and min functions to get it exactly, and then we're going to graph the second derivative to get it with zero crossings. So now we're going second calculate max min. You do it the same way you did the zero crossings. You should understand everything this derivative is showing you. So the horizontal tangents are zero crossings on the second derivative. Those are points of inflection. So if you do it exactly, you should get minus 0.89, 20.90, 1.15, 26.57, 2.74, 56.78. Those are our inflection points. And so you can see whether it's concave up or concave down by the slope changing sign. So look at how that slope changes. It's changing from negative to positive. Okay. Did you get your 3 points? Okay, those
What are the x values and y values versus y because we need to do that ready second
Well, that's after we, okay, yeah, you're getting your x values here. We're gonna get the rest later, that's right. We have to plug that in to get the rest later. Okay, now, we're taking the values that we got, for our max and min, okay, and we're plugging them into the original, and then we're gonna take these and plug them into the original. But before we do that, we're plotting our second derivative. Okay, so let's plot the second derivative. Take what you got already. Our second derivative, 20x cubed minus 60x squared minus 6x plus 56. So erase this graph you have. We're gonna go now and plot the second derivative. That y value there, this is what you get of the x location, the y value you get when you plug it back in to the original. So we're going to do that later. Thank you. So now you're plotting that second derivative. And what we're going to do is see the zero crossings on our second derivative. And they should be the same things we just got for the x value should be the same as for our inflection points we just got. So the zero crossings of the second derivative are the inflection points. And you take those and you plug them back into the original. You take your max and min points, you plug them back into the original. Get the exact locations of your max and min. This thing shut off. I don't know when it shut off. We've plotting our second derivative. So we got max and min of our first derivative doing the same thing to get the location of the inflection points. Then we're plotting this and we're getting zero crossings. You should get the same things. Zero crossings of your second derivative. You have 3 zero crossings. So for the last one, you should get minus 0.89, just like you got before. Then you should get, for the next one, you should get 1.15 for your zero crossing. And then get your last one. Okay, they should be the same one you got before, 2.74. These same values, which were our max and min on our first derivative, are the zero crossings of the second derivative. Then we're going to go on to the next one and do the same thing.
So you got this left color. That one is the same. Should be the same. So you turn it like that. You get the same answer because the zero crossings of the second derivative are the maximum of the first to this one. And then you can put back the other one.
Now you're plugging 1.5 back into negative 1.5 into the original to get the values of those max and min. And you're plugging 2.62 into the original and 2.84 into the original. Remember how we plugged them into the original? Dakota, did you plug the minus 1.5 into the original? Renee, did you plug it in yet? We're plugging these values into the original to see what is the location of our maximum.
Something as the zero crossing into the second. So let's see.
Did anyone plug in negative 1.5? Did you do it yet? No, there. They just, Dakota, did you get it?
That's 36.
Okay, so we should get right around 36.47. I'm just gonna jump the gun on this one because I want to do the more calculus part of it. If you plug in 2.62, should get 56.83, and if you plug in 2.84, you should get 56.73. Those would be the points on the graph. Okay, now we're going to go on to 3. All right, so first take your derivative in 3 and then graph it. Everything we're doing, I have in purple right here. Where it's positive, increasing, negative, decreasing, like that. Max, min, concave up, concave down. So you're taking that derivative and you're graphing that. You're going to have a different window. So adjust your window. So we're graphing 6x to the 5th minus 25x to the 4th plus 75x squared minus 12x minus 48. All right, so you're going to get your zero crossings. There's 1, 2, 3, 4, 5 of them. Let's have a window like, I'd say your Y window should be about minus 60 to 50. and your X window minus 2 to 4. So you can well see you've got 1, 2, 3, 4, 5 zero crossings. So we're just interested in the X value. Where are these zero crossings? Those are the horizontal tangents of the original graph, right? The zero crossings on the derivative are the horizontal tangents. They're the maximum of the original graph. So the zero crossings of the second derivative are the maximum of the derivative. The zero crossings of the derivative are the maximum of the original function. You should have gotten minus 1.31 for your first one there on the left. You can see in the graph that before we reach that point, it's negative decreasing. What's the second point? Nevaeh, did you get the next one?
Seems to be around 0. 0 and 0.
Hold on, I'll find this out. I have minus 0.839, minus 0.84. Okay, so we know that that second derivative came positive there. So we know we have a min here. Now let's go to the next one. Alyssa, did you get the next one yet? Okay.
Problem is you don't actually know so it's gonna okay, so you can calculate how to go with it. Okay, that's to the left of that. If you're not this up here, you can put it over. Press enter. That's what you're gonna do. And that's it. That's what you can calculate. Back up again. And it's doing this one. So you can calculate it. Yes, if you don't have to do something here, you can stop there. Press enter. Go to the right. Press enter. Press enter. That's it. I'll do the next one.
Our next one is right around 1.06 or so. 1.06. We can see that we had between negative 0.84 and 1.86, it was negative decreasing. Okay, let's see you do the next one.
Okay, you should have good. But there's two in there, right? You gotta get the second one. Let me show you this one. So if you put your cursor there, okay, you can see how it goes on the right side.
You can always zoom in if you can't see that right one crosses twice. So you should get 2.5. So it's positive, therefore increasing. Then we go to 2.5. There's a tiny difference to the next one. Dakota, did you get the next one?
2.7.
Right, it should be 2.75. Okay, so from 2.5 to 2.75, it's negative, decreasing. I've run out of space, so 2.75 to infinity is the last one. That is positive, increasing. So we have a min, we have a max. We have a max and a min. So this original graph had a lot of local max, local min. Now, you can use your max and min to get the inflection points, and we can graph the second derivative as well. Let's just use some max and min because we're running out of time. So now you go back, you've got 1, 2, 3, 4 max and min. You don't learn as much as when you do the math, do you? It's just kind of like learning what buttons to push. So for your max and min, you should have minus 1.10, 0.08, 1.72, 2.64. Those are all your max and min values. Okay, so those are your inflection points because the derivative is 0 there. So that means that the second derivative is equal to 0. Our slope is 0 on the first derivative. All right. I think we're going to stop there. I won't give you any homework on this. I know not everybody has a calculator for this. The only homework is the other stuff. So have a nice weekend. Don't forget to study for your physics test.